Hi, introduction to SPIFFE and SPIRE. My name is Emiliano Bernbaum. I work at a company, Scytale, and we are maintainers for SPIRE and SPIFFE.
My name is Scott Emmons. I also work at Scytale.
All right. So what we're going to do is just go over an introduction to what SPIFFE and SPIRE is, and just show it to everyone. Out of curiosity, how many people here have heard of SPIFFE and SPIRE? Or okay. Sweet. So here we go. So we have a bunch of talks at KubeCon. So there's obviously this one. Tomorrow, Evan Gilman and Sean Crampton are doing a Zero Trust Service Mesh with Calico. So that's happening at 11:05. And then we're also doing a deep dive into SPIFFE at 14:50 tomorrow. And what we're going to do there is really get into SPIRE running on Kubernetes. So one of the main things that we've been doing since the last KubeCon is really updating SPIRE to be able to run cleanly on Kubernetes. And we're going to do a whole demo and talk about that. Then we have secure multi-cloud with cross clusters, and that's being presented by Evan. Just you, right? Yep, just Evan. And then to wrap it up, we have a talk with Uber Security and how to build our workload identity platform. And that's going to be Tyler Julian and Dan Fellman. So there's a lot of stuff that we're presenting. So what's SPIFFE? So what we're doing is it's a universal identity for workloads. So we don't only solve authentication, but with policy, we could solve other problems. And the way we really do this is by defining a standard, provable way to provide an identity to a workload, and also a standard way of obtaining that workload and validating it. And SPIFFE is it's made up of 4 different specs, and we'll talk about each of those. And the first, what we do is the SPIFFE ID, which is how we identify the workload. There's actually a document that we serve to that workload, and we expose this through a workload API to deliver that document. And then the last thing that we've been working on is a Federation API. So this is what a SPIFFE ID looks like. It's really modeled as a URI. It's just basically just a structured string. We don't really prescribe how you should what data you should put in there. And if we break it down, the trust domain is the domain for that URI, which really describes the root of trust for where those workloads live. Everything after that, the file path is really the workload name. And you could really think of this as a primary key for a workload or a username for a workload. Now, the next thing is that verifiable document, the SVID. Currently, we support 2 different types of SVIDs. We have an X509 SVID and a JOT SVID. And we started with X509 certificates as the underlying doc type. And it made the most sense because it was widely deployed and understood. And what we really did in the spec is describe what goes in that certificate. In the beginning, what we really were doing was describing and figuring out what actual X509 extensions we'd want to use, where we would actually store the SPIFFE ID in the document, which we put in the SAN URI. And then we also describe how to validate that cert and the SPIFFE ID within it. The other document that we just recently published is a JOT SVID, which what the spec really says, it constrains what the algo does and the JOC headers that the JOT SVID supports. And what the JOT SVID does, it just supports signing of the JOT. So that's the identity document. The third part of what we're doing, of what we support, is the workload API. So the workload API is a standardized local interface where a workload could contact that API, and the API will return the identity to that caller. It really answers the question, who am I? So when the workload comes up, it talks to that API, and after it goes through a process that we call attestation, and I'll talk more about that in SPIRE, we return the identity to that workload. And what we really do is that we ensure that we have a platform agnostic way of providing this data. 1 second, So because it's agnostic, and this also works on Kubernetes or GCP or other platforms that you have, or bare metal. And then the next thing, what we've really been working on recently is Federation. And we've just wrapped up all the spec work in Federation, and we're actually in the process of implementing that inside of SPIRE. So with Federation, what we have is the ability to have 2 different SPIRE clusters talk to each other with SPIFFE compliant IDPs. And the idea is that once we have the API and the spec, that we could have other fabrics that support that spec, and we could federate with those other different systems. So if it's not SPIFFE but something else that implements the Federation API, we'd be able to peer with that and have the workloads in the 2 different environments talk to each other. And even if they don't support the workload API, we'd be able to communicate with it if they deliver a certificate a different way, such as Istio with the way it delivers certs. And the other thing is that the Federation API is compliant with JWKS spec. So what we're also doing is that we could support OIDC federation, where we could federate with an OIDC compliant system. So that really makes up what SPIFFE is, those 4 different documents. Now, the next thing we have is SPIRE. What SPIRE is the code base that we've written with the community to support the spec, to supply and implement the workload API and the Federation API. So, first I want to it's kind of crazy as we've kind of started the community that there was a recent meetup in Japan led by a team at Z-Lab and Tomoya Usami, and they had a great presentation, great slides, and I actually, they inspired me, and I copied a little bit of them, but I just want to make sure I give them credit, because it was really, really good stuff out there. But what we're showing here is that, as you have 2 different trust domains and different applications in those domains, you could assign SPIFFE IDs to the different items, the different workloads in that system, and then we allow them to talk to each other, right? That's basically the crux of Federation and what we supply with SPIRE. So looking at SPIRE, it's really made up of 2 different elements. There's a SPIRE server and a SPIRE agent that you have to install in each node that you want to run inside of your fleet. And what the SPIRE server does, it supplies this identity mapping, node attestation, which is how do we identify the node that's in your fleet. It actually also signs your SVIDs and issues them, and it also supports the Federation API. The agent will expose this workload API, and it also does the workload attestation, which is how it figures out who the workload is. So we'll just do a walkthrough. And the first thing is, I'd like to thank Evan Gilman and his artisanal arrows. Again, I'm inspired by his slides and explaining how this stuff works. But what we're doing is that as soon as you start up your SPIRE server, we could generate a self-signed certificate, which will be the root of trust for all the workloads running in your fleet. And it will be used to sign all the SVIDs for the workloads that are managed by that one server. We also have the ability to use an upstream PKI system. So we have a plug-in model where you could actually plug it into another PKI system that you have, so you could chain these together if you don't want to just use the self-signed cert inside of the plain vanilla SPIRE server. And then the last thing we do is that we expose this registration API. This is how you define what a workload looks like. So what we do is We have properties for a workload that we call selectors, and those selectors will dictate how we identify that workload running in your fleet. So as an example, here we have an example registration where we are basically saying that whoever's running in the namespace payments and with the service account staging, and it has this Docker image, we're going to identify that as the payments web workload and deliver that SVID to that workload. And that's managed through that registration API. So we'll just look at a SPIRE server coming up. So we're running this on a platform, and as soon as we come up, that server could attest any agent running in its environment. So when the agent comes up, the node comes up, the agent wakes up, and its whole thing is proving it is who it is, right? It's doing the node attestation pieces, which means that we're giving that node its initial identity, which we call the parent ID. So the attester on that SPIFFE on that node will gather proof, right? It'll gather whatever data it needs to send back to the SPIRE server to prove it is who it says it is. In AWS, this would be an IID, and in Kubernetes, we've just created a SAT and PSAT attester to use the account token attesters to prove who that workload is. But this whole system is pluggable, where we could use X509 certificates on a box or tokens that you could generate beforehand to attest that node is who it is. So once that happens, the SPIRE agent will present that proof back to the SPIRE server, and then the SPIRE server will go back and talk to the platform with whatever API it exposes. And then again, we do this through plugins. So we have a node attester plugin that we could expand and use different ones for different platforms. So for Kubernetes, we could use PSAT or SAT attesters to verify that the node is who it says it is. And then after that process is done, we will deliver the SVID back to that agent for distribution. So, that agent now has that's the identity of the node. So now going forward, when it goes back and talks to the SPIRE server, it's going to use that certificate to establish MTLS between the SPIRE agent and SPIRE server. So what we've really done here is we've identified the node that the agent's running on. So the next part is, how do we identify the workload that is running on that system? So the way SPIRE does this is that the SPIRE agent's running on that box, and we're exposing this local socket that exposes the API. So the interesting thing here is that this is an unauthenticated API call, right? So the workload could come up and talk to the socket. We don't have to inject a credential or a secret for that communication. What we rely on is the process that we call attestation, where we could introspect that workload, see who it is, see if it matches the pattern that we've registered beforehand, and then identify the workload as the set of selectors that we previously registered. So when the workload comes up, it'll try to talk to that API socket. And again, the way we do our attesters, they're pluggable, so we could run this, we could attest through a Linux kernel, or we have a Kubernetes attester, and you could write different ones. We could look at Docker images or Linux primitives that we could also use to attest that piece of code, and in order to validate the attestation. So once the workload comes up, he talks to the API socket, and we basically kick off attestation. So what that means is the SPIRE agent figures out what process tried to talk to it, and then it'll find the process and then run through the set of selectors against that workload. And then it'll gather all that information and then see if it's something that was registered beforehand. So that's just that process. And if it does match, we deliver a certificate, the SVID, to that workload. So now it could use that, and we've identified that unique piece of code. So I ran through those. So that's an explanation of what SPIRE is and SPIFFE. So what I'm going to do now is I'm going to hand it off to Scott to talk about the latest updates on the actual project.
All right.
So do you want to?
Yeah, sure.
Okay.
All right, so a lot has happened since KubeCon in December in Seattle. So we've merged over 120 pull requests. We have 3 releases that have been published. There's been 18 different contributors to the project. We've introduced 13 major features, and then also published some getting started guides and sample configurations that make it pretty easy to get started and give SPIRE a try. There's a few specific contributors we kind of want to call out for putting in some pretty big features. So Matthew and Matt from Square contributed MySQL data store. Tyler from Uber contributed node attestation using SSH certificates. Michael from Square contributed support so that the AWS Secrets Manager can be used as an upstream signing authority. Andrew from Uber submitted the ability to specify a common name or DNS name in X509 SVID so that you can kind of customize some of the additional fields in the SVID. And then there's been some other contributors from the community as well. For SPIFFE, which is a specification, there's a SIG-SPEC group, and there's been a couple of updates to that as well since the last KubeCon. Spec for JOT SVIDs has been completed, and the SPIRE implementation for that is available. And then a draft for Federation has been stabilized, and that draft really covers specifications for the SPIFFE trust domain and the bundle format for federating. Last night, SPIRE 0.8 was released from here in Barcelona. Some of the things that went into SPIRE 0.8 is I mentioned the secret manager, using AWS Secret Manager in the upstream CA. We have introduced telemetry so that metrics from SPIRE can be pushed into your favorite metric system. We've introduced some plugin and host services. And what those services are is if you are writing a plugin for SPIRE, with plugin services, you can provide a set of kind of standardized callbacks that SPIRE will use to provide or inform SPIRE of information around your plugin. You might want to use that for health checks or liveness probes, for example. So if your plugin wants to go a little bit more deeper into determining if things are okay. And then host services are sort of the opposite side of that. So something like telemetry is a standardized interface that your plugin can use to push your own metrics in through SPIRE. We've introduced the Kubernetes Bundle Notifier plugin, and this can be used to replace the Bootstrap certificate and upstream CA with another implementation where SPIRE Server injects the certificate bundle directly into Kubernetes, and then that gets mounted within agents so that you don't have to provide a static certificate for bootstrapping the agent, or if you're using currently a static upstream certificate, that goes away as well. So it makes it a little bit easier to use the self-signed certificate, and SPIRE Server just manages rotation of that all automatically. And then finally, nested SPIRE. So nested SPIRE, although this seems like it's a lot like Federation, it's very different. It allows a topology of multiple SPIRE servers within a single trust domain. So at the top, that might be a master SPIRE server running in a secure environment. Maybe on the left is Kubernetes, and maybe on the right is your on-prem data center or some other cloud. So this allows all of these environments to work together in a single trust domain, but your workloads don't have to communicate back to that master server. Instead, those calls are dispatched through a local SPIRE server. So it allows you to sort of wall in a little bit each environment and keep that master SPIRE server more secure. I'm going to go through, no, I'm not going to go through each of these one by one. This is our change list for SPIRE 0.8. But we really want to call out the things in red. These were all contributed by people out in the community, by others than Scytale, which is really great. And actually, we're near the end. So if you want to try it out on GitHub, you'll find the SPIFFE specification at the first link, the SPIRE reference implementation at the second link, and then we're on Slack at that location.
Yep.
Any questions? And I think just 1 second, the moderator will come and grab this microphone and.
Yeah, I have one question that I would like to protect my workload with SPIFFE, and it's kind of a certificate or JOT token. But I wondered how can, with my workload, to attestate that certificate wherever it comes from, or the SPIFFE token that's the connecting service shows me it's valid. Because you mentioned that it's MTLS, and that's for sure. Then when establishing MTLS, it also proved that the other party who connects to my workload possess the secret key. With JOT, there I need, when I'm verifying it, it's a valid service connecting to me. I need to get the public key from somewhere to validate it. But also this JOT token, when it comes, can be stolen. So how can I, when I'm writing a service, verifying that the SPIFFE identity, which is given to me when it's connecting, it's legitimate?
So I'm just going to repeat your question to make sure I understood. You're asking where the key material that is used to validate SPIFFE IDs are coming from. So in the case of X509CA, in the case of JWT, the public keys?
I just want to contact my service at my workload and put something in front of it that verifies and forces it's a valid SPIFFE identity. Is the SPIRE has its an agent? How can
I see.
Because if it's mutual TLS, then it's sure the TLS does it for me. But then I get TCP.
I see. So you're asking how can you secure workloads using SPIRE agents without having to necessarily update your application to speak TLS?
Something. If
Okay.
yeah.
So SPIRE agent exposes that workload API socket that you saw on the diagram. Out of that socket comes the authentication material, so that is the certificates and JOT tokens, and also comes the public keys for verifying.
Yeah.
So there's two APIs supported on that workload API. The first is called SPIFFE Workload API, which is a SPIFFE specification standard. The second supports Envoy SDS API, which is how Envoy fetches certificates. So some people will put a proxy in front of their workload and use the proxy to terminate MTLS and to do JWT verification. The SPIRE project does not do this on its own, but it will work with Envoy in that you can point Envoy at the SPIRE agent, and SPIRE agent will feed it the certificates, and then you configure Envoy to validate. Does that answer?
So for Envoy, we had a helper that would do the verification for the JOT. Oh.
So it seemed like most of what was covered mainly covered service authentication. Is there any sort of support for service authorization?
No. So we don't. We just do authentication. So there's other. So OPA just put out a blog post showing how they could do authorization with a SPIFFE ID. And the project is really, the main focus of the project is how do we identify a workload in any environment and deliver all the identities to that workload through this API. We felt that doing authorization was way too big for us and just wanted to be really laser focused on authentication and identifying the workloads. But, huh? Tomorrow's talk, yes. There's a talk tomorrow that kind of shows how we could do that with Calico.
Thanks.
I have a couple of questions. One is, when you talk about Envoy and SPIFFE, basically you're giving an identity to the sidecar, right? Not to the service.
Yes.
So any service that, so for example, if I'm managing to impersonate the service speaking with the sidecar, that's out of that domain. That's kind of like a yes or no or question, or I just want to understand that. And the second thing is that I'm thinking about is, what's preventing me as an attacker, as a hacker, to impersonate services using SPIFFE certificates? So what kind of validation is done that the one who's providing me the SPIFFE certificate is actually the same process I gave it to, rather than attributes or stuff like that?
Right. So the way you could talk to the API is through Envoy, right, or through libraries that we support, right? So we have libraries in Go, C, and Java, right? So you could do TLS termination in process, so you don't have that air gap between your workload and an Envoy or whatever proxy you're using. So yeah, you are verifying the proxy, not the actual workload. So it really, that is up to you how you deploy it, and obviously when you have that flexibility, it comes at a price, and you have an air gap between that. But that's why we also supply those libraries for you to use. And the second question was about how do I know that I'm not being spoofed by a different system or a hacker? And really, that's what we're doing is that we're defining these fingerprints for that code, right? So if you hook it up to your build pipeline and you want to register those through that, and there's that signature that you use, that's all that we could verify, right? We don't quarantine the code or anything, right? We're just trying to match that fingerprint that we know about. So if somebody spoofs and goes into your system and starts registering their own things, then obviously you have problems there. But we don't, the only thing we could do is just say that, look, this is the pattern that we're looking for, and that's what we could apply, right? So obviously the tighter the pattern is, and the more control you have over it, the better, right? But we've done, we have a whole talk and analysis that we did with the CNCF showing all the security, aspects of SPIFFE, and what are the different attacks and what kind of vulnerabilities are there if you pop one node or if you pop a server. Obviously you have bigger problems there. So we could supply that. I mean, that's out there. There's a whole spreadsheet just showing the analysis that we did. Yeah. Any more questions?
Hi, I'm curious whether or not this is suitable for, say, using with like a virtual TPM.
Yeah, do you want to?
Yeah. Yes, very much so. So, Emiliano mentioned that SPIRE is very pluggable. There's a lot of really important aspects of operation of this kind of system which are kind of offloaded to plugins, so you can make implementations which have different backings. One of those plugins is called Key Manager plugin, is used for key storage. So on the server, we have an interface that looks very much like PKCS11 that you can use for HSM key storage. And on the agent, we have an interface available which is similar, which you can use to wrap keys with TPMs and things like this. We don't have a TPM Key Manager plugin implementation in the open source project just yet, but you can certainly write your own and bring it in, and we would love a contribution if you're interested in doing something like that.
Yeah. Yeah, I mean, the one thing is I didn't go over all the I kind of glossed over all the different plugins that we support, but we have for the CA, the upstream CA, the attesters, actually the data store is also pluggable, and also the
Yeah, and it's only recently, I think, that cloud providers are beginning to expose those kinds of things. So we're looking forward to that as well.
Yeah. Any other questions? Right. I know Scott's going to hate this, but I just wanted to show a picture of a cat because we've never had a cat picture, and Scott didn't want to do it, so I'm going to do it. OK. Thanks a lot. We're here all week. Thank you.